students. Today we are going to start our second topic, that is the very most important of acids and bases, that is the strength of acids and bases. If we talk about the strength of an acid, then it's the ability of an acid to donate a proton is known as the strength of an acid. And what is the strength of a base? The ability of a base to accept a proton is known as the strength of base. Now, if we talk about examples, those acids which can easily donate a proton are known as the strong acids, and which cannot easily donate a proton is known as the weak acids. So, the very famous example of a strong acid is an HCl. Similarly, the base which can readily accept a proton will be the strong base, for example, ammonia. Next topic is ionization constant of water. As we know that water is an amphoteric substance, so it can behave as an acid as well as a base depending upon the different conditions in which it is present. In order to understand the concept of ionization constant of water, or in order to derive the equation of ionization constant of water, let us take as example in which water molecule will undergo a self-ionization. So one water molecule will act as a Lowry-Bronsted acid, and it will donate a proton to another water molecule which will act as a Lowry-Bronsted base. So we can write the Kc expression out of it, the ratio of the products to the ratio of the reactants. Now we know that water molecules are taken as a solvent over here, so we can take it on the other side of the equation, just making it a constant, because we know that the thing which is taken in excess, like the solvent, is always taken as constant quantity. So we can make an equation for ionization constant of water that will be Kw equals to the molar concentration of the hydroxide ion and the protons. So Kw is actually known as the ionization constant of water. It's actually a constant. It also depends upon, its value depends upon the temperature. If temperature is high, the Kw will be high. At room temperature, its value will be equal to 1 into 10 to the power minus 14. The next most important question regarding the paper point of view is the pH and pOH. If we want to define pH, how can we define it? pH is a very important concept in chemistry, because why it is introduced? Because the proton concentration or hydroxide concentrations are always in the powers of 10, and they are very difficult to deal with. So that is why we have taken a new concept. So the scientist named as Sorensen introduced that concept for the very first time. What is the pH? It is a negative logarithm of hydrogen ion concentration. Its mathematical equation will be negative log of hydrogen ion. Similarly, what is pOH? It is the negative logarithm of hydroxide ion concentration. It's very easy to deal the chemical equations with pH and pOH regarding the molar concentrations of hydrogen and hydroxide ion. Here a pH scale is shown to you, students, in which different substances from our daily life are mentioned over here, having different types of pH values. You can have a guess out of this that what I was talking in the previous slide, that hydrogen ion concentrations are taken in the powers of 10, and they are very difficult to undergo such calculations. So pH values are very easy to deal with. Let's suppose, let us take as an example, the substances that are acidic will be having a pH less than 7, and the substances that are basic will be having a pH more than 7. And the substances which are neutral will be having a pH equals to 7. Now, if we want to prove, we have a very short proof, that is an important short question also, pH plus pOH. its sum should be equal to 14. How can we prove it? If you want to prove it, we know already that Kw equals to the hydrogen and hydroxide ion concentration product. So we can write out the value of Kw over here, that is of at room temperature 10 to the power minus 14. And if we will take the negative log on both of the sides of equation, then it will become 14 equals to pH plus pOH. The next topic is very important, that is more important regarding your practical point of view, that is known as a titration. What is a titration? It is a very important technique in order to determine the concentration of an unknown solution in comparison with a standard solution. The important apparatus known as titration apparatus include a burette stand, conical flask, and two types of solution. One is acid and another one is the basic. The known solution will be taken in the burette and an unknown solution that is known as an analyte will be taken in the conical flask. The very important thing that we will use in this type of the titration will be an indicator. Many different types of indicators are being used in chemistry. The most famous indicator used for strong acid titrating a strong acid against a strong base is known as the phenolphthalein indicator, that is pink in color. Actually, what is the meaning of titration? We will take an acid or a base depending upon what we are going to decide. But one thing will be taken in the burette and another thing will be taken in the conical flask. Okay. We have to neutralize an acid against the base, and we have to find out the concentration of an unknown substance. An unknown substance can be acid and unknown substance can be a base. More explanation will be provided to you people during your practicals. Okay, thank you so much.